Just a little more detail I want to know about the these serverless behavior.
Go ahead.
Yeah. So what I mean, I want to know that what kind of serverless behavior is for a DB. I mean, why DynamoDB is behaves as a serverless DB, but the standard MySQL doesn't.
So it's a long discussion, right? I'm going to try to sum it. First thing is obviously DynamoDB being a NoSQL database, it's much faster compared to a SQL-based database. It's inherently faster.
Okay.
Plus, it has the ability to horizontally scale, which a SQL-based database, traditionally, they don't have the ability.
Correct.
So serverless, on the front, your compute is able to scale horizontally. But if your database is not able to scale horizontally, you're going to run into scaling issues. That's one fundamental problem in using like a SQL-based database with serverless, right? You could have the same problem with your server-based application, right? If you have like a fleet of EC2 instances deployed through autoscaling group, your application tier, or your web tier is able to autoscale, but your database is not autoscaling. So you run into the same problem. If you have autoscaling on the application and web tier, but you don't have anything on the database tier, you run into the same problem. So how do you autoscale a traditional MySQL or PostgreSQL instance? Yes, you can add read replicas, right? But they are read only. So maybe you can autoscale for the read traffic, but what about the write traffic? All the write traffic goes through the same instance, which is the master. So these are the challenges. Once again, not going into too many details, like what would be the solution for this, right? But these are the challenges that we face when designing systems. But if you use Aurora Serverless, it will scale. You can horizontally scale it. And that is something that you can use with the serverless model. Aurora Serverless gives you the horizontal scalability option, and it also gives you SQL. The world loves SQL, right? I mean, we have already established this. Even when I was studying, in our database courses, they taught us about other kind of database technologies and how they can possibly replace SQL. So like 30 years ago, people were trying to replace SQL or relational databases, right? No, they're still there. They're still there and kicking and going strong. So now I think we should just embrace that SQL databases are here to stay. That is why you have technologies like Aurora Serverless and other SQL traditional relational databases that supports SQL, that support relational design, but they can scale horizontally. Aurora Serverless is one example. There are other examples as well. There are other companies that have built these solutions which support horizontal scaling. Another problem which you're going to have if you use a standard relational database is serverless applications create a lot of connections. So when there would be a spike, you're going to have a lot of connections get created on your database, and it will run out of connection limit or run out of resources. So that is why I mentioned use an RDS proxy, because with RDS proxy, you have connection pooling, and it helps support the serverless architecture with SQL-based databases. All right. Any other questions here?
Yeah, one question relevant to Amazon API Gateway. So on this gateway, we just have the routing table. Like as you said, that AWS Lambda.
Yeah.
We have all the compute.
Routing table is not the right term to use. You define your routes. You define your REST API on the Amazon API gate. And then from the REST API, you have integrations. On the integration, you can specify Lambda, you can specify an HTTP endpoint, and there are a few more that you can specify. So that's how it works. Say, okay, this path, whatever this path is, right? When request comes in to this path, you invoke this Lambda to process it.